Rolling is a combination motion in which an object rotates about an axis that is moving along a straight line. So in this lecture video, we will only consider the objects that have a rolling motion without slipping. And to understand more the rolling motion, let's have a look at this figure. So in this figure, pinapakita dito yung isang round object or pwede rin siyang consider as a wheel na nagro-roll without slipping. Exactly one revolution. So paano naging one revolution? Yung point initially at the bottom, ito, follows the blue curve to the top. So habang nagro-roll yung wheel na yan, yung point na to is napunta dito, ito na siya, and then back to bottom. Nung nag-roll ulit yung wheel natin papunta dito, andito na ulit yung point na kinukonsider natin. So the overall position of the object ay pwede nating i-measure by dito. Say this, for example, this is the x or delta x, a change in position from x initial to x final. Ang kinukonsider natin dito is yung point. So sa first figure, nasa bottom yung point. Sa second figure, nasa top na, and then nasa bottom na ulit sa third figure. And because the object doesn't slip, in one revolution, the center moves forward exactly one circumference. So from here, nag-roll yung buong object natin hanggang dito sa third point na to, na kung saan bumalik lang sa bottom position yung point na kinukonsider natin. And ibig sabihin nun, nakapag-rotate yung wheel natin ng isang revolution, and that means that one revolution is equal exactly to one circumference. Itong change in displacement natin is equal to 2 pi times radius. Yung radius yan is ito siya, radius ng wheel. And yung time for the object to turn one revolution is its period t. And ito yung time. Now in this figure, meron tayo ditong velocity. Linear velocity ito, velocity nung point, nung center of mass, nung wheel or nung object na i-consider natin. And now we can compute the speed of the object center as this formula. Ito yung formula natin for the velocity, yung basic formula natin. Change in displacement over time, where itong t is yung period. Ito. This is the period dahil nasa rotational motion tayo. And since yung delta x natin or yung change in displacement natin is equal to the circumference, pwede natin i-rewrite yung equation as ito. Velocity of the object center is equal to the circumference, or simply the 2 pi times radius ng wheel over the period. And since itong terms na to, 2 pi over t, is equivalent to the angular velocity na omega. Ito. Ibig sabihin, pwede pa nating rewrite tong equation na to and magiging ganitong format na siya. Velocity equals sa angular velocity times the radius of the object. So itong equation na to is a rolling constraint. And again, we have already discussed this sa lecture video natin na angular quantities. This is the basic link between the translational and rotational motion for objects that roll without slipping sa velocity. Ito. This is one of the equations or the relationships between the rotational and translational. Again, rolling motion is a combination of translation and rotation. The velocity can be found for any point on a rolling object by adding the velocity of that point when the object is in pure translation without rolling to the velocity of the point when the object is in pure rotation without translating. In another figure here, pinapakita ng figure na to how the velocity vectors at the top, ito siya, at the center, and at the bottom of a rotating wheel are found this way. So yung point at the top of the wheel has a forward speed of v, ito siya, due to the translational motion plus a forward speed of ito, pag-add natin, due to the rotational motion naman yan. And the speed of a point at the top, yung top point ang pinag-uusapan natin, which has a velocity again ito, and ito, this is based sa translational motion, and ito naman sa rotational motion. The speed of a point at the top of a wheel is then, pag-aadin natin sila, magiging 2 times v or simply 2 times angular velocity times the radius or twice the speed of its center. Ito siya. Since equal lang naman ito sa translational motion, sa rotational motion, wala tayong linear speed sa center dahil nga rotational motion siya. And on the other hand, the point at the bottom of the wheel, ito, where it touches the ground, it still has a forward speed of velocity due to translational motion. Ito, pareho pa rin yan. Meron pa rin tayong translational speed. Pero yung velocity naman, due to the rotation, points backward na. Papaganyan na siya. Since umiikot, pag ganito, yung wheel natin, yung rotational motion, yung point sa taas is to the right and yung point naman sa baba is to the left. Meaning, pag pinag-add natin ito, saka ito, we find that the velocity of this lowest point is 0. Ito siya. And in other words, the point on the bottom of a rolling object is instantaneously at rest. Ganito yung ibig sabihin ng phrase natin sa lecture video na to na rolling without sleeping. Kung yung bottom point ay merong velocity, it would be moving horizontally relative to the surface. In other words, it would be sleeping or sliding across the surface. So, para makapag-roll yung isang object without sleeping, yung bottom point, yung point na nagtatouch dito sa surface, must be at rest. Example number 1. A car with tires of radius 31 centimeters drives on a road at a 70 miles per hour speed. Letter A, calculate the angular speed of the tires, and letter B, calculate the linear speed of the tops of the tires. So for this example, let's start with letter A. Alam na natin yung linear speed and yung radius ng tires. We have a linear speed given 70 miles per hour and yung radius na 31 centimeters. So, pwede na natin i-rearrange yung equation natin na linear velocity equals radius times the angular velocity to solve for the angular speed. Ito siya. But first, we have to convert muna yung linear speed na given 70 miles per hour times the factor na 1 mile is equal to 1,609.34 meters times 1 hour divided by 60 minutes. Another factor, 1 minute is equal to 60 seconds. Pwede na natin cancel yung mile, yung hour, and yung minutes. And by calculating, 70 miles per hour is equal to 31.293 meters per second. Ito ngayon yung gagamitin natin to calculate the angular velocity. Angular velocity is equal to linear velocity divided by the radius, substituting the values, 31.293 meters per second divided by the radius na 0.31 meters. By calculating, angular velocity is equal to 100.95 radians per second. This is the angular velocity. And for letter B naman, we have to calculate the linear speed of the tops of the tires. Now, babalikan lang natin yung figures natin kanina. Sa translational motion, say ito yung tire. Sa top yung pinag-uusapan natin, meron tayong velocity dito. And i-add lang natin yan dun sa velocity in terms of rotational motion naman. Ito yung rotational motion. And kukonsider ulit natin yung top point. Meron din velocity dito na pag ganyan. Since umiikot yung wheel, pag ganyan yung kanyang rotation, V, again, pag-aadin lang natin sila. So, ang total velocity sa top of the tire is 2 times the velocity lang din. And yung velocity na yan is yung given na 70 miles per hour. Velocity at the top of the tire is equal to simply 2 times the velocity. And this is 2 times the 70 miles per hour. Velocity at the top is equal to 140 miles per hour. Now, kung ang required sa atin is meters per second, ang kanyang unit, simply gagawin lang ulit natin itong conversion na to. And this is example number 1. Example number 2. A vehicle with a 0.6 meter diameter tires takes an 85 mile trip at a speed of 51 miles per hour. Letter A. What was the tire's angular speed during the trip? And letter B, how many times did the tires revolve? Again, we have relationship for the linear and the angular speed. We have given a linear speed dito. Ang gagamitin natin na relationship is yung linear velocity equals the radius times the angular velocity. And because the center of the wheel turns on a fixed point, yung speed na linear of the wheel center is the same as that of the car. Ito rin yung linear speed na gagamitin natin. Parang ganun sa problem natin kanina. Kaya lang, kailangan mo nating i-convert itong linear speed na yan, 51 miles per hour times 1 mile, ito, and this is 1,609.34 meters times 1 hour over 3,600 seconds. Cancel. And by calculating, 51 miles per hour is equivalent to 22.799 meters per second. So now, alam na natin yung angular speed. Once na-calculate na natin yung angular speed, kaya na rin natin i-calculate yung number of times the tires turn from the rotational kinematic equation. Let's start with letter A. Ito lang ang gagamitin natin. Angular speed is equal to velocity over the radius, and substituting the values, we have 22.799 meters per second, the linear velocity, divided by the diameter ng tire. We have 0.3 meters na radius. Diameter ang given sa atin. Angular velocity is equal to 75.997 radians per second. For letter B, again, gagamitin natin yung isang rotational kinematic equation para malaman natin yung number of times na umikot yung tire. Gagamitin natin na equation is yung angular speed or angular velocity equals the change in angular displacement over the time interval. Ito yung nahanap natin. Alam na natin yung angular speed. Kailangan pa natin i-solve yung time interval. And masolve natin yun using the linear speed. Velocity is equal to change in displacement, linear displacement divided by the time interval. Ito yan. Time interval is equal to change in displacement over the linear velocity. And change in displacement natin is 85 miles. 85 miles divided by 51 miles per hour. Makakancel yung miles. Ang matitira is yung hour. Time interval is equal to 1.667 hour. And i-convert pa natin sa seconds. Times 3,600. We have 6,000 seconds. Ito yung time interval. And ika-calculate natin yung change in angular displacement, angular velocity times the time interval. Substituting the values, we have 75.997 na radians per second. Multiply natin sa time interval na 6,000 seconds. And by calculating, we have, cancel yung seconds, 455,982 radians. Kaya lang, ang tinatanong sa atin is kung ilang number of turns. Take note na yung isang revolution or isang turn is equal to, one revolution is equal to 2 pi radians. So, i-divide lang natin for the number of turns, say n na lang, 455,982 radians divided by 2 pi radians. Cancel yung radians. Ang number of turns is equal to 72,571.79 turns. This is the answer for the letter B. And this is example number 2. Example number 3. From a speed of 9 meters per second, a wheel slows down constantly to a stop over a distance of 100 meters. Letter A. If the wheel has a diameter of 85 centimeters, calculate the angular velocity of the wheel at the initial instant t is equal to 0. Letter B, calculate the total number of revolutions the wheel rotates before coming to a stop. Letter C, calculate the wheel's angular acceleration. And letter D, calculate the time the wheel took to come to a stop. So for this problem, i-assume natin na yung wheel ay nagro-roll without slipping. So, and for letter A, again, gagamitin lang ulit natin yung relationship na linear speed equals radius times the angular velocity to calculate for the angular velocity. Angular velocity is equal to linear speed over the radius. Ang linear speed natin is given 9 meters per second divided by sa radius ng wheel. We have given a diameter na 85 centimeters. So 85 divided by 2 is simply 42.5 or 0.425 meters. By calculating, angular velocity is equal to 21.176 radians per second. For letter B, to calculate the total number of revolutions na kailangan ng wheel para makapag-rotate siya and mag-stop, umabot siya ng distance na 100 meters and yung circumference ng wheel is 2 pi r and bawat revolution ng wheel ay equal dun sa total distance na na-travel niya. Calculate muna natin itong 2 pi r na to. We have 2 pi times the radius na 0.425 meters and this is equal to 2.67 meters. And ibig sabihin niyan, yung number of revolutions the wheel needs in coming to a stop is 100 meters divided by yung 2 pi r or simply ito nga siya. 2 pi, rewrite na lang ulit natin, 0.425 meters. This is equal to 37.448 revolutions. This is the answer for letter B. And for letter C naman, the angular acceleration, to calculate for that, gagamitin lang natin yung isang rotational kinematic equation. Final angular velocity square equals the initial angular velocity square plus 2 times angular acceleration times the angular displacement. Solving for the angular acceleration, angular acceleration is equal to final angular speed minus initial angular speed divided by 2 times the angular position. And substituting the values, again, sa problem natin, nag-slow down hanggang sa mag-stop na yung wheel. So, ibig sabihin ng final angular speed is 0. We have 0 minus initial angular velocity is 21.176 radians per second divided by 2 times. Ito yung total na angular displacement natin. Kaya lang, we have to convert it into radians. So, i-convert muna natin. 37.448 revolutions times 1 revolution is equal to 2 pi radians and this is equal to 235.29 radians. Ito ilalagay natin dito. 235.29 radians. Square ito. And by calculating, the angular acceleration is equal to negative 0.953 radians per second square. This is the angular acceleration. And lastly, for letter D, gagamitin ulit natin yung isang rotational kinematic equation. Final angular velocity minus final angular velocity equals initial angular velocity plus angular acceleration times the time. And by derivation, time is equal to angular velocity final minus initial angular velocity divided by the angular acceleration. Substituting the values, final angular velocity is 0. So this is negative 21.176 radians per second divided by the angular acceleration negative 0.953 radians per second square. So, take note na negative ito kasi this is a deceleration na kasi papuntang stop na yung motion. By calculating, the time the wheel took to come to a stop is equal to 22.22 seconds. Kapag yung wheel ay naka-complete ng 1 revolution, yung wheel advances linearly na distance equal dun sa outer circumference ng wheel as long as there is no slipping or walang sliding na nangyari dun sa rolling motion. And this is example number 3.